G'day. I'm working on the Taylor Taylor Hobson rotary fixture thingamy indexing whatchamacallit today, and I was making up a few of the small parts, and originally I was just going to show you two of these, but then a third one caught my eye. So the parts I'm talking about are this one, which is the little ratchet latch thingy, the locking handle, and this collar. This one is pretty straightforward, but I show a technique for just squaring up thin pieces of off-cut and all that sort of thing, so that might be of interest, as well as doing the slitting and the other operations up the top here. The handle is only half done because it's going to have to be bent in situ, but the basics of doing it, shaping the end there, putting the thread on, all that sort of thing will cover. And then this one here with the wonderful profile took a little bit of thinking about and fixturing, but we got there. I've started out taking my material down to thickness, and then I've put some, well, I was going to say engineer's blue on there, but it's actually red. Oh well. And now I've traced the outline of my part. Now, that's not to work to, although there are some people out there who say, well, that's all you need really. You can, you know, work on that with a file and this, that and the other, and you'll get your shape. But what I've done is I went and measured this thing I traced it, I photocopied that, and then I went over it with a geoliner to pick up the dimensions of it. And so I've got relationships between the center of that radius and this edge and so on. And so what I'm going to do is just put that on there like that to give me a guide while firstly I need to mill that surface off so it's flat, and then I need to get that one there so it's at right angles too. Once they're done, I can then just trim that off, set that up, pick up on that edge and that edge, and then set up a boring head so that I'm actually swinging an arc through to get that radii. That radii is purely there as a cosmetic thing, but if you want to create an accurate replica, then that's the sort of thing you've got to do. I redid my outline because I thought I was being a little bit optimistic about how close I could get to the edge. So just to establish this one surface, what I'm doing is just using a parallel to line up with the scribe line, and then I'm going to be just milling across there and then coming down there and milling there to get my right angle. And that's all I'm doing. After then, I'll probably take this mark off, replace it with a new one that's sort of lines up or whatever. I don't know yet. But that's all this is here, is just to make sure I've got enough room for the material. I've got enough material to make the part, not getting too close to edges, all that sort of thing. I've got my part lined up in the mill here. I just clocked along this back face, and that means that using the coordinates I worked out earlier, I can say, well, that's one axis, that's another axis on the end there, so I can put my boring head in the right spot. While I'm there, I'll probably put the center in for the pivot point as well, just as it's here, and I've got that in coordinates. Once I've got that curve in there, it becomes a little bit more straightforward because I can then set up and mill some flat pieces. I've got my part set up in the vise here. I know that between that face and this face is 112 degrees, so I've set a protractor up and I've just tapped that in so that just kisses. So I'm now going to work down, and I just had to probably work to the scribe line. This surface isn't important, except just that it needs to be flat. It's really this point that's the important bit. This piece here was set up with the protractor on this face, so I got the right angle there, and then I just went up to my scribe line. Depth, once again, I just went down to the scribe line I had. Neither of these two faces is critical. I had hoped to come back and clean up this face because there's a definite relationship between here and here, but I had this set too low in the vise, so I had to reposition. Now, the way I did that was I put a couple of parallels like that, and then used a third parallel, tapping on the top of that, to knock that down, and that gave me this surface basically being parallel or very close to parallel with the tops of these vice jaws, which meant that surface then, because everything is in tram, is at 90 degrees to this surface, which is what I wanted. So that's just a little tip. Sorry about the rain, it's set in, it seems. To set this part up, I've just used my protractor, using that base and then knowing what the relationship is there. I put a scribe mark where I needed to go to. The final thing I'm going to do to this part today is put a trench down here for the flat spring to sit in. To set that up, once again, I'm using the protractor. What I've done here is, once again, I've used a parallel, and I'm just setting it up there so it just kisses when it gets there, and that'll give me that angle. I could set it down in the vise and use go direct on the jaws, but the problem is this part's a little tall and I start running into the bottom of the vise. It's a relatively straightforward part to make, but there are a couple of tricks which will make that a little bit easier. I found a bit of 8mm steel in the scrap bin, and from the lack of magnetic activity, I think it's a bit of stainless, which, oh well, that's what it is. One thing that is worth noting is you won't be able to put that bend in straight away. You'll have to wait until you've got the thread in the part, and then work out where the bend needs to be so that the handle isn't sticking up above the level of the table or something like that. So just something to bear in mind there. On this part, I've rounded the end off with a file, and it'll probably get a bit of a polish and all that sort of thing later, but that's good enough. I've now got to put this taper in there, so that's about 8mm there, and it goes down to 6. So the minor diameter of the thread there. So that's the next bit I'm going to do. So I'm going to do that by, first of all, I'll put a groove in there where that thread is going to stop. Sorry, where that taper is going to stop. And then I'm going to do a trick with the cross slide. So you can see here what I've got. I've put my boring bar on the back of the centre line, and I'm running the lathe in reverse. Well, that's difficult to say. A lot of the lathes that I've used, you can put the cutter over the other side of the centre line, and so what this means is that basically I've got a long thin cutter that I can put on the other side there, running in reverse. I can do what you'd call a conventional cut, and I'm just taking off a very little bit at a time, as you can see, and so I'm going to get a rounded end with a going down to a taper just there. I'm just doing this with a compound. I could set it up on the taper turning attachment, but it's for the amount of work required, it's quicker and easier to do it this way. I could also take that down with a file if I wanted to, just bearing in mind that the 3-to-1 rule applies. 3 times the diameter out. This is around about 30mm here, so I'm a little bit over that, and that's why I'm taking light cuts. But anything more than that, and you could get into trouble. But this will give me a nice tapered section like that. I then need to put a straight section there where I'm going to the bend, section where I'm going to put the thread, and then another section here for the, what would you call that, the pushing part. Now I'm going to leave that overly long because I don't know exactly where that's going to end up, but what I'm going to do is I'm going to put that on there with a die. Now that means I need to reduce the diameter there, or there on the equivalent part, so that will slide over there and I can thread. Now, if I make that significantly smaller than that, it means I've got the possibility of a drunken thread. Okay, so what I'm going to do is I'm going to put that diameter to be the same diameter as the, I can get a pin gauge in here, which is an M8 die. I can get 0.248 in there. So I'm going to take that down to 0.248 diameter. That'll mean that will guide the die on, so I can get a nice straight thread on there. And that's when that's done on fasteners, screws and things, that's called a pilot point. Very handy if you're screwing into a nut. It helps you get things lined up before you go. So I'm going to be using that principle here to take that down to just a 1/2 thou under 1/4 inch for the length that needs to be, plus a little bit extra, and go from there. Now I'm using a 3-jaw here, and every time I do something, I inch this forward in the chuck. That's all right, because this thread doesn't have to be wonderfully concentric with this handle or for that reduced diameter there. I might get a couple of thou movement because this is a newish chuck, But you can do that. You've just got to live with the lack of concentricity. If you wanted to, I guess you could put that in a 4-jaw and dial it in every time, so it was beautifully concentric. But for what this part does, there's no great benefit in doing that. This is a trick that might come in handy. I'm making up one of these. In fact, I'm making up 2 of these, one to replace the one that's broken and one to go on my table. I've got these lumps of steel sitting around the place, and they're big enough, they're fine, I think they're diameter 70, I need 66 or something like that. They're a bit thick, so I need to face them off. Now, these have been saw cut. I don't know how parallel these cuts are. When I put a square on them, I get all sorts of results. It's a bit wiggly. So, this is how I'm squaring these up. First of all, I'm facing this off. I don't particularly care how this is sitting in my 3-jaw here. I'm just facing it off. I'm then going to run down the sides here just enough so I can grab it, and that way I'll have a face here that's square to the base, so I can knock that into the chuck. I can grab hold of that, and then I can face the other side, or bring the other side down to size, and that'll give me 2 sides that are parallel. I won't get the 2 axes being beautifully concentric. They're going to be offset slightly. So what I'm going to do is I'm going to bore a 25mm hole through there, actually inch diameter hole through there, and then I'm going to put this on a mandrel. I'm going to use that then to true up the outside face, so the outside face is concentric with the inside face, the bore, and then I can put that back into a 4-jaw chuck, dial up the inside, and take that out to the 1.5 that it needs to be. And that way, out of a random lump of steel, and maybe it could be orientated like that, I can get 2 sides that are parallel and an inside and an outside which are concentric. So here I am. I've got a flat surface on that side. I've got this surface here is perpendicular to that, so I can hold that in my 3-jaw chuck. I'll tap that in. I can now face that off as I've done. And so this surface is parallel with this. I'll probably just trim that edge off a little bit and all that sort of thing. Now, I need to find out how thick that is. Conventional calipers like these don't fit. Conventional micrometer doesn't fit. So some of you may remember this. This is the multi-anvil micrometer that I made up the anvil for. Now, that's a 1/4 inch ball, that's a 1/4 inch offset, so it should all be good. But the beauty is that I can now sneak that in there like that and get a measurement on that. And that looks like that is 684. So I've got, I need to take that down to 625. So, that's working beautifully. So a worthwhile thing to have if you're doing a lot of work in your chuck like this and you've only got a small gap. This is the result of my handle making. So the bend goes in later, as I've already said. That diameter there was used as a pilot to get this going, and that took a bit of work because this is stainless and it just didn't want a thread. Probably in hindsight, if I'd started off by single pointing that, it would have been a little bit better, but oh well, it got there in the end. I've left that long so that I've got room for adjustment there. I'm not quite sure how well this will sit in the castings that I'm designing, but that's the handle. One thing there was that when I was tapping this thread, once I got it started, I actually switched over and tapped it that way and tapped up. And that was simply because this being a tapered section was difficult to hold in the vise. Whereas that being parallel, I could just grab that and off I went. I was going to bore these out in the lathe, get everything nice and concentric, but I discovered that the amount of step on my chuck jaws versus the amount of height meant that I couldn't really put a packer behind, so I had something soft to bore into and hang on to the part. So what I did was I roughly bored them out on the lathe, got them down to within a couple of millimetres where they need to be. I've now set them up on the mill here, and I'll get the boring head in and bore that out concentric to this. I've already sort of zeroed the DRO on the outer edges there and gone from there. Sometimes when trying to find the edges of round things, it's a bit difficult So what I've done here, I've put a couple of parallels on top of the vise, and then I've put a third one on top of those, relying on the squareness of the sides there. That's then pushed up against the round edge, and I can indicate off that or at least I can find that top edge there more easily because it's a nice sharp square one. So just a little hint there. I've now done the major work on the clamp rings. I was actually a bit more involved than I thought it would be. Basically counterbore that with the appropriate sized end mill, drill down with a tapping drill, drill down with a clearance hole, then come across with a slitting saw and put the slit in. And because I was clamping like this, so I had the clearance for the slitting saw, it was wanting to move around a bit, but we got there in the end. So thanks for watching, and we'll see you for the next one.